So I'm back, and this is what we left behind. I've been busy, so for now we can run with the running speed, we can walk with the walking speed, we can crouch with the crouching speed, also with the right collision. But how about this? How can we prone? We cannot prone, and so we are to make a stand, crouch, and a prone system for our game rather. And I've recently learned about the finite state machine uh, technique that is implemented in the game development, and it's actually finite state machines are the ones who manages the transitions between the states, the current state to the next state. And yeah, we are to implement that one. But for now, let's organize the folders because my folders are very cluttered. Create the animations of uh, stand to crouch, crouch to prone. Yeah, and then implement the FSM itself. So for now, let's organize the folders. Okay, so we've organized it, and then moving on to the animation. Let's open our character scene. Okay, so for now we do have our crouching animation, but we don't have the crouching animation for standing and proning, standing to crouch, and crouching to prone. Where is it? Yes. So stands to prone. For now, let's create the stand to prone because it's easier. Hmm. Stand prone. So in our collision, we currently have the height of 2 meters. 2. Let's get that one. No, the the mesh first. Mesh, and then let's lower it to 1.20. Yeah, 1.20. It looks like a ball. Anyways, looks good. Also for the collision, this is also 1.20. Okay, good. Now we have to lower it to the ground. Let's put it to 1 meter to from 1 meter to 0.50. Yeah, that should suffice. Anyways, 0.50. But first, let's get the initial value, starting value, and the 0.50. 50. Looks good. And now, if you see here, the camera does not move. So we have to get the camera value also as the same as what we've done. So currently it has a value of 1.5. Let's get that initial value and 1.20, 1. Oh, 0.70, lower, 0.5 rather. Yes. It looks good. Okay, Now put it to cubic so it would be more smooth. Control save. Now it looks good. We now have our stand to prone and prone to stand animation, hence stand prone. Is it running? Hello? Yes. So we've created it. Now to stand to crouch. Manage new. I wait. Crouching. Yeah, this will serve our stand to crouch animation. But the collision is not, the mesh is not working properly. So get the mesh, initial height, and then put it to 1.5. Get it also. Also put it to cubic. Okay, good. Looks good. So let's rename this one to stand crouching. Yeah, let's put it stand crouching. Yep. Now that's done. Now crouch to prone. Crouch to prone. Wait. So let's have a review. We are making an finite state machine for our stand crouch prone system, correct? So we have to stand and then to prone, stand, prone, prone to stand, and then stand to crouch, and then crouch to prone. So we are to make that animation for our transition. So let's create here stand crouch prone, no, prone crouching. Yeah, it really depends on how you name it. Okay, so this is my way. You can you can name yours in a different way. So for now, it starts from crouching to prone, correct? So this so the end value for our stand crouching would be the initial value for our prone crouching. So 1.5 and then 0.75. Go back to the prone crouching, get the collision, mesh height, and then the collision height. Don't forget the position, and also don't forget the camera rather. There it is. Okay, now go back to the mesh. Rather than 1.5, let's put it to 1.2. Yes. Also the collision 1.5, 1.2, and then the position would be from 0.75 to 0.50. Good. And as you can see, the camera is not also moving, so we have to move that one also from 1 to 0.50. Yeah, let me check if it's correct. Yep, it is. Also don't forget to put it to cubic so that it would be more smooth. Nice. Are they all in cubic? Maybe. Yes, they are. Okay. Control save. Hello, is it running? Yes. Crouch prone. Initially, we are done with our animation. Uh, it's so cold here and it's raining so bad. I'm drinking my coffee. So, we are now to make our finite state machine. And actually, I've made an article here about the stand crouch prone system with a node based approach, finite state machine, and Godot 4. So, I have here, this is my visual vis, visualization. I have here my visualization of our finite state machine. So we can stand to prone, stand to crouch, but from standing, and prone to crouch, but from proning. Now you might be asking, why are there two types of crouching? And I will explain it as we implement it in our game, but I will skip most of the sections here and we are to focus the building part. So for now we have here our structure, correct? Character, state machine, standing, two types of crouches and proning. We have here our scripts attached to them, and these are a separate script. The state one will be a base script that will be inherited by the player state. And then the player state will also be inherited by our individual states. And these individual states will set the behavior of our of our node. That would mean this script will define that this script that is attached to this node will define that the player will be in the player's standing state. So why is this connected to the character script? That means it is referencing the character to the player state, connecting the character to the individual states, because the individual states has inherited the player state. So essentially, player state acts as a bridge between the character to the states, which are the individual states are controlled by the finite state machine, which is the finite state machine is used to acts as a manager for the transition between the states. So that's a lot of thing to process. So let's get to the very basic. What is the definition of the finite state machine? So it does act as a manager for managing the transition states, which are the standing, crouching, and proning. And then the states refer to the condition of your character, whether standing, crouching, prone, jumping, running, resting, or in other positions. So those are it. And we are to build that. And yes, I will explain it later. But for now, let's focus on building. Again, we have here our character node, animation node. And let's create a node that would be our state machine. And then yes, the children. Another node, Control D. This would be our standing state. This would be our stand crouching, because it would be crouching from standing state. And then this would be prone crouching. This would be prone. Now we are to make script for this, and then the separate scripts, which are the state and player state. So let's create a new folder to make it more organized. states. There it is. And let's create a new script, which would be our state script. There it is. So this state script is this one, and this article, or the one that we are making, is actually based on this one from GDQuest. And most of the code there, specifically from the state machine script and the state script and the player script, is from them. I've only copied those code, but as for the individual state code, I made them. So please check that out if you need more, or if you want more details. So for now, let's create the state script. I have it here. Yes. So this is the state script. As you can see here, class name state extends from node, signal finished, and this would be the virtual functions that will be inherited by our player state. And we are not to make our player state. This one. Of course, there would be an error first. And then, wait, let's get back to our structure. Oh yeah. So we did the script for our state, and we just did also our player state script. We now make our state machine script. Be mindful, or just double check that it would be on the states folder, just to make it more organized. And then this is the state machine script. And this code has been copied from GDQuest, and they are better for the explanation for it. But for what I know is that here, yeah, I think you would understand this. But this is a IIEF, which stands for invoked immediately invoked expression function. Yeah, immediately invoked expression. Is that correct? Immediately, yeah. What? No. Yes, I am correct. So it stands for immediately invoked function expression, which is a function that calls itself. So this function will call itself, which is for getting the initial state. And then ready function, it finds these children of the states, which is from the parent, which is a state machine. And then this is for handling input. And then this would be the transitioning next to the state. Anyways, most of it is to manage the states in here as its children. If you want more explanation, please go here from GDQuest, and they are better for explaining it as they are the one who made it. Anyways, let's go back to our state machine and then go to our standing state. Okay, I do have my code here. Oh, there it is. Oops. That was close. Let's put it in our states folder. Touch script, also states. Prone crouching. Mm. Okay. Now it's basically done, I guess. So let's go back to our world setting. Let's delete this one. And then let's reinstantiate our character. Don't make it local because you would trigger this. The player state type must be only in the player scene. And this is actually where the referencing takes place by referencing the player state to the character script. Okay. Oh, wow. Okay. Can we crouch? We cannot crouch. Do you know why? Of course, it's because the project settings in the input map has not been set. So, crouching. Let's go back to our um, standing or the individual state script and go see to the and check the input. There. So if input is action just pressed, crouch or uncrouch, we do not have this, and we also don't have this. So if we go to our project settings, in fact we don't have those, we only have crouching. So we are to make those crouch or press C for crouching. As for proning, we name it prone or unprone, and let's put it to Z. Okay, run. Oops, stand crouching, invalid access to yes. So as you can see here, animation speed. Let's go to our character body 3D. It says here crouching animation speed. Now how did our is it proning? No, crouching, I guess. Yeah. So how did the individual stand crouching script was able to know that we have a variable crouching animation speed from the character body 3D? That is because if we go back here, that is because we used our player state to reference our character body 3D. Again, that acts as a bridge from character body 3D to the individual states. So if we go to our player state, we have referenced our character player here. Wait. Oh, we don't have. Oh, there it is. Character player. So we now have successfully referenced our character player to our player state script. as you can see here. The character player owner as character body 3D. Now, again, let's go here. And where was us? Where was we? Where was I? Oh yes, how was the character body 3D? I mean, how was the stand crouching script was able to know this value? I mean, huh, was I correct? I don't know. For now, let's reset. Oh yes, so we cannot access the animation speed because there is no animation speed in the character player. But how was the stand crouching script was able to know about the character player, which the character player is within the character GD script? How? Again, that is because we use the player state to reference the character and connect it to the individual states, because the individual states has inherited the player state, essentially making the player state as a bridge between those character body 3D and these individual states, which are managed by our state machine. So yes, but for now, let's rename that one to animation speed, because we are not only setting the animation speed for crouching, but also the standing, crouching, and proning. Oh yes, there's also anyways, let's delete this one to prevent conflict, because this is the old crouching code blocks. Error. Yep, but don't mind it. Okay, crouching, we can crouch and stand. Excuse me. Can we prone? Yes, we can prone. Can we crouch from prone? Yes, we can. Can we stand? Oh, yes, we can. Anyways, let's see how this works. And let's get back to our question, why we have two types of crouching. Actually, it has been already answered in here in my article. Yes, let me explain. So why is there two types of crouching? Because originally my state machine only had one crouching, as it says. I only had this one, and my finite state machine before looked like this. So we can stand. Wait. So we can stand, exit standing state, and enter proning state, and then exit the proning state and enter the standing state, exit the standing state and enter the crouching state, and exit the crouching state and standing state. So that was the only movements that I can perform at the moment, this one and this one. But how about standing, crouching, and proning? Because I was making a stand, crouching, proning system for the game. But sure, we can modify it into this. So exit, we can we can stand, prone, crouch, and crouch to stand. But how about if we move our character consecutively like this? And there would be a problem. But for now, let's act as the state machine for now, following this. So stand, it says from stand we have to prone. So from stand we have to prone, Here it is. Exit the standing state and enter proning state, and the current state would be in the proning state. And then the next move would be from proning and goes to the crouching state. So we exit the proning state and enter the crouching state. Yes, we can make it. Yes, we are able to crouch in this current setup because we have separated the crouch. But we are following the old one, which we has only one crouching state. So that would mean we would not, the final state machine would not know which crouching crouching to take, because we have different types of crouching. Stand and then crouch, and then prone to crouch. So it's about the animation. We have to make the animation accountable. So it does not know what crouching that has those animation to take with one variable crouching. So it does not know. I mean, we do not know. However, if this was run or the code was compiled in a computer, the finite state machine you implemented would either take one here, would either take this one or this one, because it's a computer, and it basically does what you tell it to do, and it would have conflict. So anyways, now exit the proning state and enter the crouching state. However, we do not know what kind of crouch will be performed. There it is. Are we to perform crouching from stand or crouching from prone? The flowcharts seems feasible, yes, but the coding part requires additional complexity. It gets complicated, leading to conflicts and unintended results. So anyways, my solution was to separate the crouching state, which considers the animation for crouching. So standing and crouch, and proning and crouch, those two types of crouching. And this is how our finite state machine, which is the current one, works. This is the FSM visualization currently. So let's try. So we go standing to prone, stand to prone. We are proning, we are able to prone, and we want to crouch. So from proning, it goes to crouching, but that state was the crouch from prone, but essentially we are crouching. And then if we want to stand, it would then exit the crouch from prone state and press C to uncrouch. It would go to standing state. But if you want to crouch, it would go here, crouch from stand, and if you want to prone again, it would go to the proning state. And if you want to stand, of course, it would exit the proning state and goes to the standing state. So yes, so that would be it. Wait, but before that, let's go back to our code. You might be confused here. The func enter, and then the func ready. There's no ready. Anyways, the difference between the function ready and the function enter is that the function ready initializes once once for the scene. It's for the scene initialization. And as for the enter function, it initializes for the state. So it runs every time once the state is activated. So that is the difference between the two. And let's see, let's play a game once more. Yep, crouch, prone, lower prone. No. I guess the speed would be the next one. But essentially we are done with it. And yeah, that's it. That would be it.